Alright guys, so in the last video we started looking at a pretty simple example using y equals x squared, our basic parabola function. So now we're going to kind of try to amp it up a little bit and look into one where it might kind of test us a little bit more so in terms of as to where actually this function is going to be increasing and decreasing over the interval. So let's take a look at the example. Y equals 3 plus sine x through the interval 0 to 2 pi. So first and foremost, remember kind of from our previous example, in order to find out what's happening in terms of concavity, we have to use our second derivative test. And so first and foremost, let's find out what that second derivative is. So first derivative, the derivative of 3 becomes 0, and the derivative of sine we know is going to be cosine of x in this case. Well, now we need to find the second derivative, so the derivative of cosine we know to be negative sine x in this case. And so now we just got to kind of think of what's happening from the specific spots of the graph itself. And so if you think about what's happening between 0 and pi specifically, we know that it's going to be concave down, because if you're looking at the graph of y equals 3 plus sine of x, we're going to give us something of the nature that looks as such, right? And so let's say we have 0 here and we have pi down here. We know that all of the tangent lines are going to lie above our particular curve between 0 and pi. And so this would be considered concave down from 0 to pi. And then we're looking from pi on to 2 pi to kind of wrap some things on up with our particular interval. In this case, we have from pi to 2 pi. We'll put 2 pi out here. And then all the tangent lines you see that we can create from pi to 2 pi are below our curve. And so then our curve is going to be above it all. We consider that one going to be concave up in this case. All right. So what I want you guys to do is give this one a shot on your own. And let's take a look here at using a very basic function. Find the concavity of y equals 4x cubed plus 21x squared plus 36x minus 20, okay? So determine where the intervals are going to be. So kind of use what we've been talking about with our first derivative test, kind of go a little bit backwards now. Determine for part A where it is concave up, and then for part B, determine where it is going to be concave down. Now this might be in multiple spots, but remember guys, we just need to kind of find out what's happening to the left of the critical points for y double prime, or for the second derivative specifically. So give that one a shot. This is number 7 in your books on page 215. To kind of give us our answers for our double check, we can see that it's going to be concave up from -7/4 to infinity, and then it's going to be concave down from -infinity to -7/4. So check your answers on that one, guys. Make sure you're on the right track, and we'll go over it first thing.